Right, the madness has started. As you can see, I've ripped it out. There you go. Right, if you've seen me post on forum, you'll see that I powered it up. And when I powered it up, it was just as expected. It was the control were dead. So anyway, cut a long story short, a few phone calls to Fadal, people who know Fadals. Soon become apparent it wasn't worth repairing. The cards were expensive. They basically just said swap the cards out, and not knowing which card it was just didn't make it feasible. I don't know anybody with one of these machines, and I wouldn't ask them to lend me cards anyway. The Fadal engineers would come out, but they wanted a fortune. Wasn't over helpful. So end of the day, the control's old anyway, limited on memory, difficult to drip feed it. Well, not difficult, but hassle I don't want. So I decided to rip it out. Anyway, so we ripped it out. As you can see, we've set about tracing wires and found out where all the different sensors are, things like that. Sort of, we've got sensors under there for the arms in and out. There's one on the carousel in there for spinning around. Micro switch there, which is basically protection for the carousel in case the tool doesn't let go. That arm slides up and down. These are Belville washers, so it acts like a spring, and it trips this switch if the tool doesn't let go of it. The drawbar doesn't let go of the tool. If it lifts the arm up or pushes the arm down, that'll trip. So we figured all that out. A couple more sensors here on the spindle. One for the drawbar, one for the spindle orientation. A couple of pneumatic devices that have to be controlled. One puts this arm in for spindle lock. The other one is for the drawbar. So simple enough. Trace the wires on the motor. There's basically just the encoder and the power for the fan. The fan's off, it's there, it's in there. As you can see, a lot of wires, masses of wires. This is the top of the machine. There was a bunch of wires in here that were like this fat, it were ridiculous. This underneath this cover, it filled the hole with that tray, went down through this hole there. Anyway, what I will do, all this stuff on the back of there, that'll be all swapped, changed. I won't use the keyboard. I'll keep hold of the switches and the MPG and stuff. PC will go in there. Control will be an Ethernet control, so it'll just feed an Ethernet cable back into the control box. Show you the carnage that's gone off in there. As you can see, that's what you call gutted. All we're keeping, basically, for sure, 100% is the power supply, which is a 5 and 12 volt that feeds a distribution board. It's 5 and 12 volt. There's 120 volt relay there to turn the power supply on, basically just like you would turn a PC on. Turn that on, turns that on. The only other remaining thing there is this bit here, which is the 4th axis drive. As you can see, is there the fan, capacitor and the bridge rectifier for the DC side of it. That may or may not be stopping. The reason being, I've decided to change all the motors. The motors are here. The motors are getting changed out for AC brushless servos. A bit like this one. This is not the motor. This is a 110 frame. I need a 130 frame, a little bit bigger, so it bolts on there. Nothing wrong with these motors. Good motors. Decent quality motors, very strong and powerful. The DC brushed motors, so they've got brushes, and they also use resolvers. Resolvers, very good, very reliable, but they are getting long in the tooth. It's harder and harder to find drives that will use resolvers. They all want to use encoders. They're very expensive as well when you find them, so I decided to, because I'm going to all this trouble, I'm going to bring the machine up to modern standards. I don't want, if the machine ever goes down on me, I don't want to have to be sat around waiting to find resolvers or brushless drives, whatever, brushes for the motors. AC motors are readily available. They're more than capable, and I can get one next day. So that's the decision on that. That's done. The motors are off. They're going. And the crazy thing is, I can probably get as much money selling these second hand with the drives and the cards and everything that control them to existing Fadal owners as that would cost me to put a set of motors on. Or if it doesn't cover the cost, it'll go a long way towards them. So it's a bit of a no-brainer in my eyes. It also allows me to run step and direction, because the modern drives will take step and direction or analog, which sort of ties in with the next bit. The reason why I might not use this is I haven't decided what system I'm going to run it on yet, what controller I'm going to use. Because the fourth axis, this is the fourth axis, uses a DC brush motor with the resolver. That's the resolver there. It means mixing step and direction with analog signals if I want to use this. Which complicates things a little bit because there's not many controllers can do it. In fact, there's only one controller can do it, and that's Linux and Mesa cards. Now, it's a little bit involved. It's a little bit of a waste of card because the resolver card is a 6-axis card and I'd only be using 1 axis of it. The whole setup would involve 3 cards basically, which involves the main control card, then another card for the encoder inputs for the drives, and then the resolver card just to run the 4th axis. Gets a bit complicated, so the other options are change the encoder, the resolver for an encoder, and that does away with the resolver card. The encoder card that will fit to the Mesa system has more than enough axis, so I can just use that. So that's one option. The other option is to get rid of it altogether, sell it, and that's what I'm debating to do. The reason being is it's worth quite a lot of money. The price of these things is crazy. For instance, the kit for a 4th axis consists of this connector box that goes in the roof there, which plugs into the cable there, the drive, an axis card that plugs into the main control, a solenoid for the brake because it's got a brake on it, a brake, air operated brake, and a few other things like the disconnect switch, the overheat disconnect switch, and a few other little bits. And that kit, that's without the 4th axis itself and the motor, is $4,000. And that's and with that, your machine has still got to be wired. And by that I mean it's got to have this harness. There's an harness there. Look. Go and get it. Stand still. This harness with the plugs in, which basically runs up through the machine, out through the top, and goes to your plug that's in there. And that's got to be fitted in the machine already. So that's $4,000. If you haven't got this wiring harness, you've got to buy this harness, and that harness alone is $500 from Fadal. It's just madness. The 4th axis itself, God knows how much there is. It's a Japanese, it's an high quality, it's a good quality Japanese unit. I reckon there's about 10 to 12 grams worth in total. If you had to buy this kit to put it on the machine when it were new, that's the sort of money you'd be paying. So the option is to sell it. I can sell it complete with the harness, with the cards and everything, and they all work, so it's quite a valuable thing on its own, and I don't know how much I want or use a 4th axis. So this is a bit of my dilemma. The other dilemma I've got is the machine. When I've done the machine, I'll probably sell it. So I need to work out if keeping the fourth axis and make it work adds more money to the overall machine or not. It'll certainly make it more saleable, but how much value it will add to it, I don't know. So if it adds sort of 3 or 4 grand at value at machine, and I can only get a couple of grand for that second hand, I'd be better keeping it on machine and just having the aggravation of setting it up. Still to be decided, but I need to decide soon because I've got to work out what goes in here. So back to which controller to use. Working on the fact I'll do away with the resolver and put an encoder on the fourth axis. It limits things, it opens things up a bit rather, so it takes the limits away. However, I don't want just the closed loop. I want it to be fully closed loop back to the controller, not just back to the drives, which then starts limiting my options again. So the options, Linux is in the option and is the main one. Then I've got other systems like Dynamotion's K-flop and Canalog system. That will close the loop for me. Centroid will, not the Acorn, but the Oak will. The Acorn's not got enough for I/O and it can't close the loop, but the Oak can. All them systems will let me use stepping direction or analog, so I could run it in it. Well, I definitely have to run the fourth axis analog because it's an analog drive. The drive's analog, which plus or minus 10 volts. The AC servo drives will let me run either or, I can step in direction or. I'd like to get away from analog because it's a bit of a bear to set up at times, especially with these old amplifier cards, these things. So I'd like to get away from that, but I can't if I keep the fourth axis. So if I work on dumping the fourth axis and selling it, then it gets simpler. But I'm still limited to the controllers because of the full closed loop. So my options go, like I say, Linux, K-flop, Centroid. There's a couple of other expensive options. The Centroid's expensive. It's sort of, by the time I've done it, it'll be 1,500 quid to 2 grand. Bit too much money. K-flop's the next dearest. That'll be, I don't know, 500 quid, something like that by the time I get it here. The Messer cards are a little bit cheaper. So at the minute, Messer's winning. I don't know the K-flop and I don't know Messer. I don't know either of them. So there's a learning curve. I haven't had anything to do with Linux CNC, but I know a man who has had a lot to do with it, Clive, which is offered to help me. Thank you, mate. And then there's the forums. I'm no duck egg. I'm plenty of experience with CNC, so I'm pretty sure I'll work it out. And between us, we'll get it going. So that doesn't faze me too much. Although I'm not stupid. I know it's going to be a big challenge and a bit of a learning curve, but I'll do it. So that's the option. It's looking like Linux CNC is what all this rambling is about. It's just whether I keep the fourth axis or not. Linux will let me do whatever I like, to be honest with you. I can have it any way I want if I'm prepared to mix and match. So that's my decision, my next decision. There's a few things in this board I could put back in. Like there was a board, which is this board. And basically that's just a relay board. These are solid state relays. A couple of ice cube relays. They're just fused relays. There's a circuit breaker. They were controlling various things. I don't know without looking what they were. I've had these boards off to map them out. There's 2 boards. That's the other one, which I'll explain. Basically, they work off 5-volt logic off these pins that control these relays. 120 volts gets pumped through these, so basically these are controlling these connections here. These are doing the switching. I've mapped it all out. I know what does what. Now this connector is just tied to that connector, so something like 20 pins up, 22 pins on there control this, and another 14 control this, something like that. Anyway, it's simply a pass through, and there's a cable goes from there to that one. This board I'll keep, and I'll show that basically where that lived was in there. Goes in the bottom of there, just there. Now that board basically handles all the control of the spindle. So basically it goes like this. These are two run capacitors for the motors for the tool change arm in and the carousel. And they're basically controlled using these relays. So these two solid state relays, these two fuses, this, I think it's a retrippable fuse, I'm not sure, I don't know what that is, and that relay there control forward, in and out movement of these. It basically switches the motor from forward to reverse, moves them in and out. Well, no, it doesn't do that. It switches the motor forward and reverse using one of those capacitors, run capacitors. These two relays, and that relay are for the carousel, forward and reverse. So that's what that does. These two relays, along with these two solid states there, they control the spindle forward and spindle reverse. And there's a couple more relays there that control the pneumatics. One does the power drawbar, one does the spindle orientation arm that locks it in place. And they use these solid state relays which just plug in. There's two different types. That one's a 3 amp, same control voltage, 3 to 32 volts DC. And then you have this, just like a circuit board type, which are 1 amp. So they're 3 amp, they're 1 amp. So that will be reused. Now, I don't think I'm going to need that. So all I will do is I'll put this back in. The cable that goes from there, that ran between the two boxes, I'll just plug that back in and cut the end off and connect the end up to the controller, to the outputs, to switch these various things on and off when required. That said, when I've worked it out, when I've had a bit more time to think about it, I might put that back in, and then if that's the case, we'll just control it from this big one, connect them back up, and we'll control it all in one. I'm not sure, because although the solid state, they're only single contacts. I don't know what I'll use them for. Maybe not. They're quite expensive. These things are quite expensive. I've seen them at something like $22, I think it was, or pounds. I'm not sure, but they're not cheap things. That's about it. In the back, worked out in the back what will be kept. The vector drive, the cover's off it, so we can see what's going off. I've actually had the spindle running, which is simple enough. I got that running. It's just a VFD basically. It works out like this. That's the encoder from the spindle motor. So that's the feedback from the motor. That's the encoder output back to the controller to close the loop. And these basically boil down to, that's your 0 to 10 volt for your speed reference voltage, and then you've just got a ground, forward and reverse. There is a fault signal there that I've disconnected because it was, with the control not working, it was showing as a fault, so it wouldn't start up, so I pulled it out. Rather than mess around tracing wires, I just disconnected it, which it will go back in when I set it up. So basically we just fed it a voltage through this, jumped the wires across for forward or reverse, and bingo, it fired up. I did I did chip myself a little bit, because when we fired it up, the motor smoked, and we were like, oh shit, turn it off quick. But when we looked, it was just damp. It's been stood 5 years, this machine, so there's a bit of damp going there. That's why there's a bit of green on the top of the moulder where the fan cover's been on there. plus the fan wasn't on. So anyway, once we realised it was just damp and let it run a bit longer, it burnt off any excess moisture and it was fine. So it was a bit of a twitcher. But pretty much everything in here is going to stay. These are the Y delta connections for high and low speed. Basically what happens is when you command the speed at highest and lowest speed, it'll switch over from one to the other. And basically this what happens, the micro switch sends a signal down this wire to the vector drive and tells the vector drive it's gone into Y mode. And the drive then switches from one set of parameters to a different set. So it boosts the torque and what have you for going slower. Simple enough. So we'll keep all that. That's just a disconnect switch, which works in conjunction with that. Overheat and disconnect, so that's what that is. This is basically just an inrush setup for the main transformer. The transformer, it'll stop as 3-phase. We're only really using the 415 3-phase for the spindle. The rest of it's going to stay at 110, because that's what it basically transforms to. And then there's it transforms, there's three powers come out of that. There's 240 3-phase, 110 single phase, I think it is, I'm not sure, there's 110, I think it's single phase, yeah, 110 single phase, and something like 100 volts, something like that, which you use for the DC side. So depending on what I use, that'll stay that. We'll probably not use the DC side. Well, we won't use the DC side if we dump the 4th axis. But pretty much that'll be as original when we've done. As you can see, we've ripped. The motors are still on up there, but we've took all the wires out. They're just ready for unbolting. We took that silly system off. Don't know what the hell that was, but that's gone. Same there, the motor's still on, but they're all disconnected on the wires. I'll pull them off soon. We took a few things off the side. It had some of these American style 2-prong American style 2-prong power outlets for the coolant pumps. There's a blank on there. I think that's it really. You can see we've been all over the machine. There's wires hanging out everywhere. The amount of wires we took out is crazy. Crazy. It's more wires there. And this is how crazy it gets. That little bungle of wires there was a spare set of wires in case you wanted to put another axis on it, 5th axis. It was just in the energy chain up to the Z axis. So that is basically a wiring harness for an axis, and that is $400 that I've got in my hand there if you were to buy that from Fadal. And that just ran up through the cable chains and stuff. Obviously I'm not leaving it in there, I don't need it. I'll reuse the wires. So I think that's it for now. Just keep watching this space and you'll see how we go along. Yeah, that's it. Happy New Year to you all.